Broadcasting live. It's America's longest running talk show on computers. It's Computer America, bringing you the biggest names in technology with guest interviews, new products, and your emails. Listen live at computeramerica.com on any device around the world. Email the show at live@computeramerica.com or find us on social media. Be sure to check out our website for contests, giveaways, show notes, live video stream, podcasts, and more. You're listening to Computer America.
Hello, everyone, and welcome into the Computer America Show. We are the nation's longest running, nationally syndicated radio talk show on computers and technology turned podcast. Everyone, welcome into the program. I hope that you're doing well and you are ready for today's show because we have the one, the only Mr. Ralph Bond, and we'll be joining him as we talk about 4 amazing stories that I was just, quickly browsing through them. And ladies and gentlemen, it's going to be a completely different world in a couple of years. My goodness, the things people are up to, it's crazy. So with that being said, ladies and gentlemen, definitely want to stick around for that. But before we get to that, computeramerica.com, that's where you'll find everything, including past shows, future shows, show notes, articles, all that and more. Anything that we do here at Computer America, you can find on our sites. With that being said, you can also find the show notes. The show notes are super important for Ralph shows, especially because he does an amazing job of, putting everything that we talk about together in one convenient place. So if you want to find the articles, more information, that's always an option. Go to our site and you can find it there. So with that being said, let's just jump right into it. I really don't have a lot more to say. I hope that you've had a fantastic week and you are ready for a great show to lead you into hopefully a fantastic weekend. So once again, he is our science and tech trends correspondent. So his purview is anything science and technology touches, which turns out is pretty much everything. That's like saying anything that uses the letters to form a name. It's really across the board. You never know what these shows are going to be. So, ladies and gentlemen, once again, Ralph Bond. Ralph, how you doing?
I'm doing great, and you're so right. We cover quite a lot of territory here every Friday. And friends, if you're new to the show, what Ben and I do each Friday is highlight 4 recent articles that show us key trends and developments in, get ready, artificial intelligence, robotics, medical technology, sustainable energy technology, transportation advances, agricultural technology, space research, physics. Wow, you name it, all across the board. However, most important of all, we're going to give you an oasis of positive news thanks to the world of science and technology.
Absolutely. And I think we're going to go ahead and just start with story number 1 of all these stories. And I'm just saying, when I put a hole in a battery, my phone explodes. When these people put a hole in a battery, they change wearables potentially forever. So, Ralph, let's start with story number 1 and how battery technology could get a little bit more flexible.
Yes, absolutely. This comes from interestingengineering.com. The headline is U.S. team creates holey battery. Now, we're not talking about something from the Vatican. We're talking about HOLEY, creates holey battery with 180-degree flexibility for wearables. And we have the link, and we have all kinds of information in the show notes here to augment that along with the illustrations that Ben is showing you in part here. And here's a little comment from me before we jump into the article. This is a great example of how something so simple and direct can be a game changer. So unlike some of our stories, which get into exotic research and exotic chemicals or exotic quantum computing or you name it, this is pretty darn straightforward, but simply ingenious for its simplicity. So researchers from Yale University have developed an innovative holey, HOLEY, battery that is both more flexible and breathable than conventional batteries for wearable applications. And wearable meaning your clothing, garments, jackets, that kind of stuff. This could pave the way for making lithium batteries a perfect fit for wearable electronics. And so, Ben, I don't know your experience with wearable electronics, but a lot of times they involve these rigid batteries, and we'll talk about that some more in a bit.
Yeah, it's the world of wearables is wearing a Fitbit right now, and just it always feels like you have something like a block of something just strapped to you. It's and when it comes to flexibility, getting out there, getting active, which I know you look at my body shape and you think this guy's never been active a day in his life, but when you try, it very much is just, Ralph, you become very aware that you're wearing something that is not moving with you, is not moving naturally, and it bothers you. It's not comfortable by any means. So there's a lot of improvement that could be made.
Absolutely. And so going back into the article here, it says currently most batteries have limited use in wearables, as you just were explaining, especially for applications that could result in significant wear and tear. And then my comment, I'll inject here for a good example of this. Look up battery heated gloves for winter, and you'll see that rigid batteries are needed. And I even included a picture I grabbed from Amazon.com of this kind of product. Typically, you have a battery, rechargeable battery. It's rigid, a block of some sort. You insert it into the object in question, and then you recharge it when it's run out of juice. All works, but it adds bulk and weight to any kind of wearable. So as the Yale University research team noted, quote, the rigid and non-breathable nature of conventional batteries has remained a significant limitation for wearable electronics, particularly in applications involving dynamic physical activities. So, however, this new holey battery, a battery with holes in it, could solve many existing battery problems with a relatively simple solution. The team took a flexible lithium-ion battery pouch. So you really need to see the pictures of this to get it. So they took a flexible lithium-ion battery pouch to achieve it and cut a series of horizontal and vertical rectangular holes into it. And these pouches are also relatively easy to make and comprise conventional electrode materials and hot-pressed consumables. So, Ben, the point here is they're not inventing this from scratch. They're taking something that's already out there and doing something as simple as cutting holes into it and transforming it into a much, much more practical product. I love this story.
Yeah, and for those who are able to watch the video portion, I guess they're at a trade show, it looks like, and they're and one of the people showing off their product, and you see there that she has this 3D printed looking scaffolding where it has the battery inside, and you can see she's kind of like, if you imagine like a cell phone battery, Ralph, like this is not something you could do with a cell phone battery. It looks like one of those snap-on wristbands that that used to exist. Much more flexible, and you can imagine that in many kinds of wearables. So very cool.
It is cool.
Yeah, that I don't know. It's been a problem, I guess. I just didn't know they had a solution for it, and it seems so simple.
And a simple solution too. Yeah. I just love that. That's the part about this. It's so cool. And in passing, in terms of the recipe for this, it talked about hot pressed consumables in the show note. If you want to geek out and learn about that, I've got a little side note injected in there for you if you want to check that out. But by adding a series of holes, the team found that the battery pouch was very flexible while retaining much of its power. The simulation of the design also showed that the battery should be able to be stretched or folded 180 degrees without tearing. That's that flexibility you were talking about there, Ben. And not only that, but the team found that when the battery is stretched 10% or folded, the battery could resist physical stress and continue to power LED light bulbs in their test. The team confirmed this by stretching and folding the battery over 100 times. They also found that the new holey battery could better resist fluctuating temperatures and humidities. It appears the new battery is roughly twice as breathable as cotton. What? Wow.
There's a lot to like about this article. There's also a lot of I think research like this is pretty early stuff. You may not see it in your products next year or even this year, but still, Ralph, like I'm curious about its ability to resist like puncture, and I know they said 100 times and it won't tear. When will it tear? That's a question that I think, because by still using lithium ion, lithium has that pesky little habit of reacting to oxygen and exploding when exposed to air. So I'm curious about, what is the feasibility of putting this in, let's say, pants or shirts or other kinds of clothing. I don't know, but it's obviously a huge step forward than anything that we've had before. So very cool.
Well, you make a really good point at the end there about that. That's an excellent point. But again, my takeaway from this is an existing technology, these lithium battery pouches, and simply cutting holes into it transformed them into something much more viable and flexible and adaptable. So that's the part that I thought was so kind of amazing.
It absolutely is, and as soon as we can put batteries in more places, it seems like such a small thing, Ralph, but it would enable us to do so much more. So it's as soon as we can, and we can do it safely and cost effectively, it's going to open up a whole new market. So very, very cool story. Story number 1. Story number 2. Speaking of flexible and stretchable, hey, similar kind of thing. Imagine all the things that we could do. Although plastic has already enabled us to do so much in our world, Ralph, it's just, what's going to stick with us our entire lives is microplastics. They're going to be with us forever. I don't know what to tell you, but hey, if there's a future, there's going to be a future where we still use plastic. It just hopefully will be recyclable. So let's talk about story number 2.
Yes, this comes from an announcement at Princeton University in specific, of course. Headline: Stretchable, Flexible, Recyclable. This plastic is fantastic. This is really a fun story, again, from Princeton University. We've got a link to the research paper. We have a link to the engineering news release from this university. And I love this story for so many reasons. But here we go. Princeton engineers have developed an easily scalable 3D printing technique to manufacture soft plastics with, get ready for this, programmed stretchiness and flexibility that are also recyclable and inexpensive, qualities not typically combined in commercially manufactured materials. Wow, there's a mouthful in that one paragraph alone.
Mm-hmm.
So in an article in the journal Advanced Functional Materials, a team led by Emily Davidson, and we have a picture of her in the show notes, reported that they used a class of widely available polymers called thermoplastic elastomers to create soft 3D printed structures with tunable stiffness. That's the programmable, tunable stiffness. And you might think, oh, okay, so what? No, there's a huge so what here coming up. Engineers can design the print path used by the 3D printer to program the plastic's physical properties so that the device can stretch and flex repeatedly in one direction while remaining rigid in another. And if you just let that soak in, that's pretty profound challenge.
Yeah, and I'm sure the article's going to get to where that's going to be applicable, but yeah, to just do that from a strictly engineering standpoint, I'm sure is a great feat and something that hey, 3D printing enables them to do. So
yeah, this is really. It may sound a little mundane because it's plastic. Okay, it can stretch and flex and repeatedly in one direction while remaining rigid in another. You go, oh, okay, so what? There's a huge so what here. And this next paragraph highlights this. This approach to engineering soft, architected materials could have many uses, such as soft robots, medical devices and prosthetics, strong, lightweight helmets, and custom high-performance shoe soles. Wow. The key to the material's performance is its internal structure at the tiniest level. This part's really cool, Ben. Check this out. The research team used a type of block copolymer which forms stiff cylindrical structures that are 5 to 7 nanometers thick. And for comparison, human hair measures about 90,000 nanometers. We're talking about these little cylindrical structures this 3D printing achieves that are 5 to 7 nanometers thick. It's incredibly tiny.
Yeah, like 20,000 times smaller than a human hair. That is crazy.
I know. And all this inside a stretchy polymer matrix. Now, friends, this is geeky. If you really want to get into this, you need to get the research paper and dive deeper. But a little side note here, a block copolymer, which was mentioned in the recipe here, is a type of polymer consisting of long sequences or blocks of different monomer units linked together. These blocks can have distinct chemical properties, and when combined, they create a material with unique characteristics, and you can go into the show notes and learn more about that if you want to. But going on here, the researchers use 3D printing to orient these nanoscale cylinders. So picture in your mind these infinitely and unbelievably tiny cylindrical structures that are 3D printed. And so they used 3D printing to orient these nanoscale cylinders, which leads to a 3D printed material that is hard in one direction, but soft and stretchy in nearly all other directions, as we alluded to a moment ago. And designers can orient these cylinders in different directions throughout a single object, leading to a soft architecture which exhibits stiffness and stretchiness in different regions of the object. I know this is a little hard to wrap your head around, but the illustrations in the article will help you out better as well. And to wrap things up, as a next step, the research team expects to begin exploring new 3D printable architectures that will be compatible with applications such as wearable electronics and biomedical devices. Wow.
And hopefully they get the manufacturing of these things, because it sounds super, so tiny that the production of this, they're only holding objects that are, if you're watching the video portion, you can see they're, a couple inches in length, and, they show different, these things in different ways that, yep. Ralph, I'm wondering if, when they have the cost of this down and they can kind of do it, as they need it basis, I can imagine cast maybe being made out of this, and they allow a little bit of flexibility. And then it's like, okay, instead of going from, completely plaster immobile thing to, free control, you kind of gradually go up in stiffness and bendableness, and you kind of guide it. There's so many things that you could do with this, and although they even say that, can be expensive for the other stuff, but still there are possibilities. And I've never heard of, just tuning it on such a nanometer scale. Yeah. That's crazy.
I know, that is nuts. And again, this is a good example of what we do every week, folks. A lot of our stories are early research. Where this goes, can it be scaled up? Can it be practical? Can you combine these kinds of things they're creating to create a sole of a tennis shoe? TBD. All of this is wait and see. This is just a glimpse of where we might be going in the future.
For sure. So there you go. And if you want to find out more, the Princeton article has more information, but yeah, did a great job of encapsulating that. So that's story number 2. Story number 3, I guess you could say out of this world. NASA, they've been up to some things, and they have a lot of projects going all the time. Like if they aren't sending something off into space, they're one of their other projects that they started 10 years ago is coming to fruition. NASA's always fun to pay attention to, and it looks like as of last week they may have another one with something called SPHEREx. So Ralph, what's SPHEREx?
Yeah, this is really fun. From space.com, a wonderful outlet. Headline: NASA's SPHEREx, that's SPHERE and then lowercase x, infrared space telescope is launching this week, which the headline was from last week, so it actually was a week ago today. And the headline of the article goes on to say, here's why it's a big deal, and we're going to find out. So we've got links, we've got pictures, all this good stuff. Here we go. NASA's latest space telescope, SPHEREx, which is short, of course, it's an acronym. And get ready for this one, short for Spectrophotometer for the History of the Universe, Epoch, and Reionization and ISIS Explorer. Okay, say that real fast.
I feel like, Ralph, they're stretching the definition of an acronym. Like they're just picking what letters they want. So okay.
Yeah, we'll give it to them. And they asked AI to reverse engineer it back into a believable acronym.
Exactly.
But anyway, this was launched into space on top of a SpaceX Falcon 9 rocket, again on the 28th of this February, from Vandenberg Space Force Base in California. So the $488 million mission is designed to map the entire sky in 3D in wavelengths invisible to the human eye. Wow. Map the entire sky in 3D in wavelengths invisible to the human eye. Love it. And the 2-year effort aims to gather a big picture view of more than 450 million galaxies and more than 100 million stars in our home galaxy, the Milky Way. And this will give us a comprehensive catalog of all objects radiating in the universe by measuring the glow from hundreds of millions of galaxies, including those that are too small or distant to be seen by other telescopes, according to the NASA announcement. Pretty amazing, Ben.
It is, and I'm probably the thing that I'm most shocked about so far in this article is the $488 million price tag. That is a surprisingly small amount for
Agree.
a 3D map of the entire visible, or at least I should say invisible, universe.
Yeah, I'm with you. That number blew my mind as well. So going on here, it says, scientists say the treasure trove of data will answer fundamental questions that can only be addressed by examining the universe from a broad, all-encompassing perspective. And these include why the large-scale structure of the universe appears as it does, how galaxies form and evolve, and the origins of water and other key ingredients for life in our galaxy. Wow. Go out and get the show notes, folks. Check out this announcement from NASA. And they have a wonderful website, by the way, explaining all of this. It's really, really worth your time. It's quite exciting.
Yeah, very, very cool. And the satellite's not much of a looker, but hey, it's a looker in the invisible spectrum. So, there you go. No offense, NASA. Okay, so story number 3. Story number 4, we're going to go ahead and, sometimes we've been doing articles lately about, this one is medical, for sure, roles in the U.S. military, so that's a little bit unusual for story number 4s around these parts. But, when it comes to biomedical, being able to tweak and tune humans ourselves is definitely an area and a field that not just the military, but scientists all over the world, and just kind of fixing things, re-engineering things, making things better is on everyone's mind. And I guess story number 4 is no different.
Yeah, this is really interesting stuff that comes from Business Insider. Headline, irresistible headline: the U.S. military wants to explore blood biohacks to boost warfighter performance in extreme conditions. And again, from Business Insider. Wow. Okay, let's get into this. Excuse me. The Defense Advanced Research Project Agency, which we all know by the acronym DARPA, the Pentagon's top research arm, wants to find out if red blood cells could be modified in novel ways to protect troops and help them manage extreme battlefield environments.
For some reason, that immediately brings to mind the new Captain America movie where, you have Harrison Ford playing the big red Hulk. Maybe they're trying to go for that. I don't know what the military's up to, but maybe they're trying to make Red Hulk. Who knows?
Yeah. That's funny, man. I know exactly what you're talking about.
Yep.
So the DARPA program called the Red Blood Cell Factory, and we have a link to this, is looking for researchers to study the insertion of biologically active components or cargoes in red blood cells. So this is, talk about twinkle in the eye, this is a program that they're just beginning to kick off. The hope is that modified cells, blood cells, would enhance certain biological systems, thus allowing recipients such as warfighters to operate more effectively in dangerous or extreme environments. And red blood cells could act like a truck carrying cargo or special protections to all parts of the body, since they already circulate oxygen everywhere, the blood system, that is. And DARPA's experiments wouldn't be conducted on people or animals, just bags of blood. The research would allow scientists to identify how red blood cell modification could evolve over time. And this research, as you can imagine, Ben, could impact the way troops battle diseases that reproduce in red blood cells, such as malaria. Ooh, yikes. And the modified red blood cells might allow medications to last longer without a service member having to ingest them daily. So instead, relying on doses that protect a person for weeks or months instead of just 24 hours. Now, Ben, I'm sure like me, you're thinking, well, this is great for soldiers, but what about people in hospitals? This could be magnificent.
Yeah, to be able to give people, that emergency treatment, and then, give them, according to the article, not just hours, but weeks or months to go seek further treatment. That is incredible.
It is. And the next nugget from the article is also profound beyond the military. Another possibility could be modifying cells to allow them to stop hemorrhaging after a traumatic injury, such as a battlefield wound. Wow. And such advances in bioengineering could be a game changer, to say the least, in fields like infectious disease treatment and oncology. Of course, that's cancer treatments, illnesses that require long periods of drug treatment. So, yeah, it's for DARPA. Yep, it's for the military. But again, it's research like our friends at NASA do, research that rolls over and benefits things outside of space research, right? This is a great example of that, and of all things coming from DARPA. So, fun story.
Yeah. When you think about, some basic things like you could say GPS is my usual go-to. Initially it was a military kind of thing and research, and GPS was something that the military uses. And Ralph, I can't imagine the world without GPS. It's something that, every single person who drives a car is intimately familiar with how, turn-by-turn navigation nowadays. Military research is important research because it, like you said, it rolls over. It can help everyone. And this is a really incredible one, how to save lives. So I like that one a lot. That one is a great one to kind of head out into the weekend on. Although, ladies and gentlemen, if you're out there and you're following along in the show notes, out at computeramerica.com, you may notice story number 4 is not the end of the show notes. We have honorable mentions at the end, and these are stories that we simply don't have time for. We try to keep our shows more compact, easier to listen to, and therefore Ralph has numerous stories that just don't make it onto the show. Not that they don't make the cut. Ladies and gentlemen, if you're out there and your story makes it onto an honorable mentions, that's okay. It's still perfectly good. It's just don't have time. But we can at least give the nice folks, Ralph, the headlines, and they can go out to the website and pick up more on it. So yeah, let's go ahead and do the headlines.
Okay, you got it. We got 4 of them for you this week. First one, interestingengineering.com, headline, terabytes of data in a millimeter crystal. New technique can transform microelectronics. So there's some research in the storage world. Very cool. Next one from PV, which is Photovoltaics magazine. Headline, U.S. startup unveils world's largest transparent organic photovoltaic window. Wow.
Very cool.
That's kind of fun. Next one comes from bioengineering.org. Headline, University of Science and Technology of China unveils innovative 19 degrees of freedom biometric prosthetic hand with enhanced dexterity. Wow. The illustration alone is worth checking out. That's a really cool one. And then last but not least, from technoscience.net, new era for digital storage thanks to terahertz light. So in our honorable mentions, we have 2 storage-related technology advances. So check all these out. Really good stuff.
Just when we're talking about maybe magnetic storage devices, kind of going the way of the dodo, now we have, them increasing their capacity even more. So very, very cool. Ladies and gentlemen, if you want to find out more, please feel free to head on out to computeramerica.com, and we'll have the show notes in their entirety right there, so you can check that out. Ralph, I want to thank you so much for coming on the show every week and doing this with us. It's always a lot of fun. And ladies and gentlemen, if you want to find out more, computeramerica.com as always, and you can find all the show notes, past shows, and all the archives right there. So until next time, thank you so much for tuning in, and we will catch you then. Have a great weekend, do something fun, and we'll be back next week with more Computer America. Have a good one. Bye, everyone.